So hello everyone, myself Pratiksha Thora. Today we are presenting cardiovascular risk prediction, that is a ML problem, which is a classification. So the project summary: the data set is from the ongoing cardiovascular study of resident of the town of Framingham and Mascular. The classification goal is to predict whether the patient has a 10-year risk of future coronary heart diseases. Then so here we are performing the EDA and also the machine learning model like k nearest neighbors, logistic regression, naive Bayes decision trees, support vector, machine learning, random forest and XGBoost. So I chose this project because once I wanted to be a doctor, but that didn't happen. So here I am making ML model to help people. So let's start. Here is my GitHub link, and the problem statement is to cardiovascular diseases are the major cause of the majority of worldwide. According to the WHO, 17.9 million people died from CVD in 2019. According to, for 32% of the all global fatalities through the CVD cannot be treated, predicting the risk of the diseases and the taking the necessary precautions and the medication can help to avoid severe symptoms and in some cases even death. As a result, it's critical that the accurately predict the risk of the heart disease in order to avoid as many fatalities as possible. Therefore, the problem statement is to develop a machine learning model that can accurately predict individuals' risk of developing CVD by incorporating a wide range of variables including demographic, clinical, lifestyle factor. The model should be interruptible, reliable and able to provide personalized risk prediction that can aid in the development of the prevention strategies for higher risk individuals. So knowing your data, the data set is from ongoing cardiovascular study which contains Framingham and Massachusetts data that and the classification goal is to predict a 10-year risk of coronary diseases. It includes 4,000 record and 5 attributes. So the attribute is a potential risk to factor, and there are both demographic, behavioral and the medical risk factors. The demographic is sex, that is male and female, the age of the patient, then the education, we will see that. Then the behavioral contains is the patient is smoking or not, if smoking, how many cigarettes per day. Then the medical history, if the patient have the medical history like BP, stroke, hypertension, diabetes and the medical, that is current, that it contains the total cholesterol control, then systolic BP, then diastolic BP and the body mass index, then the heart rate and the glucose level. So let's start. At first we import all the necessary libraries like here. Then I mounted this project into my drive. Then we loaded the data set, and the first data set look is that head, that means the first 5 rows of data, and the tail, that is last 5 rows of data. Then we got the 3,390 rows in this data set and 17 columns. We can see the data set info here like floats, integers, objects, non-null values and null values also. Then here we checking the description of the data. Here we contain mean, standard, minimum and the percentage of each of the columns. Then we run a code for the duplicate values, but we got 0 duplicate values. Then we are looking for the missing values. So here we can see some missing values. So here we visualize the missing values. So we got 550 missing values here. So here we understand the variables like all the columns, then description of our data. Here we check for the unique values. We can see here that sex contain 2 values, male and female. The education have 4, 1, 2, 3. That assumes that it represents the heritage and education qualification level of among the patients. Is smoking, BP, meds, prevalence of stroke, hypertension, diabetes, and are nominal by binaries where 0 representation no and 1 that represents yes and no. Each patient is in the data set are unique and there are no repeated data. And next here we renaming the columns as per our convenience. So next here we distributing the data set in 3 variables, that is dependent variable, continuous variable and categorical variable. Then we encode the binary column, then all missing values, then we see here all missing value in cigarettes, that means cigarettes per day. Then here we got the mean median number of cigarettes per day. So in all the manipulation we got there are 3090 rows and 17 columns, out of which 10-year CHD which is the dependent variable is predictable. 2 of these features are not numerical, that is integer or float data type. There are no duplicate data in the data set and all values in ID columns are unique. There are 150 missing value in the data set, with 304 of them is in glucose column. So we are replacing the missing values in the categorical column with the most frequent entry. So here we done that. So here we get the cigarette per day. You can see that there is a 20 cigarette per day is really common. It is higher in number. So it also contains missing values. So here we handle the missing values in here. Then we go for a total cholesterol, BMI and heart rate. So here we see the most common heart rate is between 60 and 80 beats per minute. There is a long tail to the right distribution, which suggests that there are small number of people with very high rates. The distribution is slightly skewed to the left, which suggests that the heart rate is more likely to be higher in younger people than the older people. Then we check the outliers in that. The median heart rate is 80 beats per minute. The interquartile range is 20 beats per minute. That means 50% of people in the population have the heart rate between 60 to 100 beats per minute. So here we impute missing values, then mean median of that, then we go for a glucose. So glucose have 304 missing values and we distribute that. The glucose column is positively skewed. So it also contains outliers. The distribution is positively skewed. Then there are 304 missing values in that. If we choose to impute them with the single value of mean median, we will adding the high bias of the point. To avoid this, we can impute the missing values using KNN impute. If the dataset is question had been a time series, we could have used that interpolation method to use impute missing values. So after KNN imputation, there is no massive change in the values of mean, and values of mean, median and mode remain the same. The KNN impute has converted all the columns to the float 64 data type, hence changing the column data type according to as per the kind of data stores in the respective columns. So we are changing the data types and then checking the missing values. So we got 0 missing values. So we have successfully handled all the missing values in the data set, and then we starting the data visualization. So in first chart we can see that the common number of cigarettes smoked per day is 20. There is a long tail distribution, meaning there are small number of smoked, very high number of cigarettes per day. Then the next chart we are going for, next chart, sorry for that. The first chart shows more men at risk of cardiovascular diseases than women. The percentage of men who are risk at cardiovascular disease is increasing day by day. The percentage of women who are at high risk of CHD is also increasing, but by the slower manner than the men. Then we already seen the second one. We are going for the third chart. So in third chart we can see that the majority of people in the population have the BMI in the normal range. There is small percentage of people who are underweight, and there is a larger percentage of people who are overweight and obese, that they will that mean that they will have CVD in future. So in next fourth chart we can see here that the majority of CVD patients are over the age of 50. The number of CVD patient is increasing in the older age groups. So the CVD is a major cause of death for adults over 50 age. So in this chart, fifth chart, the majority of CVD patients have been the higher cholesterol level. The number of patients with the high cholesterol level is increasing. The patient with the high cholesterol levels are at the risk in the further complication of CVD, such as heart attack, stroke, peripheral artery and diseases. This is the sixth chart. It shows that the number of cases of CHD has been increasing over the past few years. So in seventh chart we are seeing the relationship between continuous variable and dependent variables. So in this, by just looking at the plots, we can observe that the age is a major factor contributing to the risk of the CVD. More number of older patients have the risk of CVD than the younger patient, and more number of non-smoker are present among those who have no risk of CVD in the next 10 years. The volume plot of cigarettes per day is more flattened in the case of those two with the risk of CVD. The plot of blood pressure, BMI, glucose level show only minute variation, and nothing conclusive can be established. So next we see relationship between discrete variable and dependent variable. Here we can see that male have the slightly higher percentage of CVD, that is 18.5% compared to female. Those with a lower level of education have the higher percentage of CVD, that is 18.4%. A close second are those with the highest level of education is 14.5%. A very little effect of smoking on CVD risk can be observed. Smokers have about 16% chance of CVD risk, while non-smoker have the 14%. So next we are analyzing the BP meds. So here we can see that it can observe that those taking BP medication have significantly higher blood pressure values, while those not taking medication have the slightly lower values. This is logical observation, since according to the Medline Plus, BP medication are recommended when the levels are over 350 per 80 minute heartbeat. Also, all of the people taking BP medication have had history of hypertension. Hypertension is a direct factor for the high risk of CVD. Then in the 10th chart we see distribution of discrete independent features. So here we can see that there are more number of female present in the dataset than male. Assuming that the value of education feature are hierarchical is a ascending order, more number of people are less educated in the dataset. Only 100 people are taking medication for blood pressure. Then we are analyzing the education variable. So here we can see that the most common CVD risk factor are high blood pressure, high cholesterol and diabetes. There are significant gender difference between CVD risk factor, with men being more likely to have the high blood pressure, cholesterol than the woman. So in this chart we can see that patients with the diabetes are much higher risk of CHD than the patient without diabetes. The risk of CHD increases with the severity of diabetes. So in this plot we can see that in this scatter plot we can see that there is a positive correlation between the di BP and the cis BP. People with the higher di BP tend to have the higher cis BP. The correlation between the di BP and the cis BP is not perfect, meaning that there are some people with the di BP who have low cis BP and vice versa. So in correlation heat map we can see magnitude heat map for all the continuous variable in the data set. The variables systolic BP and diastolic BP are highly correlated. And in pair plot we can see that there is a positive correlation between BMI and heart rate. This means that people with the higher BMI tend to have the higher heart rates. So here we are starting multicollinearity. To handle multicollinearity between these two independent continuous variable, we can replace these two columns with the new variable pulse pressure, which is given follow. So we are creating new column for pulse pressure and dropping systolic BP and the diastolic BP. Then here we can see the columns. Then updating the continuous column. It were run when I run that. Then I double run it got error. Then we are analyzing the distribution of pulse pressure. The pulse pressure is positively skewed. Then we are going for a relationship between pulse pressure with the dependent variable. On average, the patient with the higher pulse pressure are exposed to the coronary heart diseases. And the correlation heat map we already seen above. Then we are going for a feature selection. So in feature selection we are going for null hypothesis, two variable are independent. Then alternative hypothesis, that is two variable are not dependent, where then we are getting the choice score, then p value for the discrete feature, then plotting p value for the chi-test for the discrete feature. So here we can see that the prevalent hypertension column has smallest p value. We can say that the most important feature among the categorical independent variable which determine the outcome of the dependent variables. Then we are dropping the is smoking, then dropping the smoking also, then checking for the outliers. We can see the outliers here. We can see that there are outliers in data. The effect of the outliers can be reduced to some extent by transforming it. Then we are transforming a continuous variable to reduce skew. Then skew for log, then implementing log transformation on the continuous variable, then checking skew after log transformation. Then we are analyzing the distribution of the continuous variable after transformation. So here we can see that expect 6 per day we have successfully been able to reduce the skewness in the continuous variable. Now this distribution are closer to the symmetric distribution. So checking the outliers for transformed feature. So here we can see that except age and cigarettes per day columns, the rest of the numerical columns contain the outliers even after long transformation. To handle this, we can impute that the outliers beyond 3 standard deviation from the mean, and it's the median value on the trained data. So then we are data pre-processing. We are defining dependent and independent variable. Then we are choosing the prediction model, then evaluation matrix. Then we test, train and split. Split here the function to get recall, then test, train, split. Then we are handling the outliers in the trained data. Then we are oversampling here. Then we are visualize the target variable after the SMOT. We have successfully overlapped the minority classes using the SMOT. Now the model we built will be able to learn from both the classes without the bias. Then we are scaling the data here. Then we are implanting the ML model. At first we are going for logistic regression. So in the logistic regression we get false negative with the logistic regression of 50. Then we go for a k nearest neighbor. So in that we get false negative using KNN, that is 44. Then we are going for a Naives bias. So in here we get false negative after using Naives bias, that is 74, 72. Then we go for decision tree. So in the decision tree we can see only one feature, that is age, was given importance while fitting a decision tree model. This is because of max depth being 1. Then we created confusion matrix, and here we get false negative, that is 35. Then we go for support vector machines, and here we get false negative, that is SMV51. Then we are going for random forest. We are fitting RF model with the best parameter, then fit, train, then recall, test prediction, then test recall, then classification, then feature importance. In features other than the age are also given importance. In this case, instead of just one feature in case of decision tree, but age still remain the most important feature in the predicting the final outcome for the random forest. So here we get false negative. Then we are going for a XGBoost. So in XGBoost we are using grid skew to find best parameters. The best parameter for XGBoost is classifier fitting. XGBoost is the best parameter. Then we are getting fit, then train, then recall, then test, then classification report. So here we get the classification report also. Then the feature importance. Age is the most important feature in this deciding the outcome of the variable for the XGBoost. Multiple features are given importance rather than just a feature case of decision tree. Then we are going for confusion matrix, that we get false negative. Then here are the results. Here we get the logistic regression 69.42 train recall, then the 64.70 test recall, the k nearest neighbor 84.76, then test recall is 58.82, Naives bias got 56.32 train and 43.13 test, then decision tree 77.07 and test 39.86. Then the support vector machines 75.73, then 61.43 test recall. Then the random forest got 78.66 and 57.51 test recall. Then XGBoost 80.94 and 9%. So here we can see that the random forest has the highest recall score on both the train and test set. This suggests that the random forest is the best model for this data set. The support vector machine and the decision tree also have the high recall score on both the train and test set. Naives bias, k nearest neighbors and the logistic regression have the lower recall score on the both the train and test set. The recall score for the train test is similar to the model, which suggests the models are not overfitting the data. The higher recall score the random forest, vector machine and decision tree suggest these models are good for identifying positive instance. This is important for the data set, and it is important to correctly identify all the positive instance. The conclusion: we trained 7 machine learning model using the training dataset, and hyperparameter using tuning was used in some models to improve the model performance. To build the model, missing values were handled, feature engineering and the feature selection was performed, and the training dataset was oversampled using SMOD to reduce bias on the outcome. Recall was chosen as the model evaluation metrics because it was very important that we reduce the false negative. Then initiate the state predictions were obtained using the baseline model, that is logistic regression model, and other commonly used classification model were also built in the search of better prediction. Predicting the risk of coronary heart diseases is critical for the reducing fatalities caused by the illness. We can avoid deaths by taking the required medication and precaution. If we can foresee the danger of the skewness ahead of time, it is critical that the model we develop has a high recall score. It is okay if the model incorrectly identify a patient as a high risk patient because it is not result in death, but if a high risk patient is incorrectly labeled as health, it may result into fatality. We were able to create a model with a recall just 0.77 because of limitation data available and the limited computation power available. A recall score of 0.77 indicates that out of 100 individuals with the illness, our model will be able to classify only 77 as high risk patients, while the remaining 33 will be misclassified. Future developments must include a strategy to improve the model recall score, enable us to save even more lives from the diseases. This include involving more people in the study and include people with the different medical history, etc. From our analysis, it is also found that the age of person was the most important feature in determining risk of a patient getting infected with the CHD, followed by pulse pressure, prevalent hypertension, and the total cholesterol. Diabetes, prevalent stroke, BP, medication were the least important feature in the determining the risk of CHD. Thank you so much, and thank you so much Alma Better to give me this platform to